Okay, so part 5 of solving quadratic equations discusses the discriminant, so discriminant. Now, the discriminant is a value that can help you to determine the number of solutions and the type of solution. So it determines the number of solutions and type of solutions. It doesn't tell you what the solutions are. If you want to determine the solutions, you're going to have to solve the equation, and you can solve all quadratic equations using the quadratic formula. But in the quadratic formula, remember this is quadratic formula right here. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the radicand. So the discriminant is just b squared minus 4ac. That's the discriminant. Nothing else. It is not the square root. It is not the quadratic formula. The discriminant is the radicand. So the discriminant is b squared minus 4ac. All right, so that's called the discriminant. The radicand is called the discriminant. That number, whatever that number is, now you can go back to the previous lesson, and when we solved using quadratic formula, that number right here, whatever that number is, whatever that value is, whatever the radicand is, it will determine the type of solutions and how many there are. Okay? All right, so let's kind of review something for a moment, though, and then we'll discuss the discriminant when we get to it. So let's solve this equation. And we're going to solve using the quadratic formula. All right, so this is a review. All right, so let's suppose we had, number 1, 9x squared minus 12x equal a negative 4. All right, so I'm going to solve this quadratic equation. So, and we're going to solve it using quadratic formula. So remember, though, if you're going to solve a quadratic equation using the quadratic formula, you have to make sure it's in standard form or general form, meaning that you want every term on one side and 0 on the other. All right, so we're going to add 4 to both sides. So I'm going to get 9x squared minus 12x plus 4 equals 0. And once you do that, remember you had to determine a, b, and c. So a is a coefficient of x squared, so that's 9. b is a coefficient of x, so that's a negative 12, not 12, but a negative 12. And c is your constant, so that's a positive 4. And so then what you did was you plugged it into the formula. So remember the quadratic formula is this. Since my variable is x, here's the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac. So remember b squared minus 4ac is under the square root, it's under the radical. And now you know it's called the discriminant. All over this whole thing is being divided by 2a. Alright, so let's plug in these values into this formula. So remember, this part says I take the opposite of b. So b here is a negative 12. The opposite of a negative 12 is a positive 12. Plus or minus the square root of b. Remember, you use parentheses in this little part here. So negative 12 squared, that's b. b is negative 12. I'm squaring it. Minus 4 times a is 9, times c, and c is 4. All over 2 times a, so that's 2 times 9. So I get 12 plus or minus the square root of, now negative 12 times negative 12 is a positive 144. A negative times a positive is a negative, and then let's see, 4 times 9 times 4 is 144. All over 2 times 9, which is 18. Simplifying the radicand, just like you did in the previous lesson, we get 12 plus or minus the square root of 0 over 18. Square root of 0 is 0, so I get 12 plus or minus 0 over 18. Now 12 plus 0, 12 minus 0, that's just 12. So I'm going to rewrite this as 12 over 18, and then reduce, simplify, that's going to be, they're both divisible by 6, so that's going to be 2/3. So notice this quadratic equation had just one solution, and it was a rational solution. Notice this is rational, and I just had one solution. All right, now, remember in a previous course that this was called a double root? Or double solution? Because if you really wrote it out twice, remember this would be 12 plus 0 of 18, 12 minus 0 of 18. In this case, you get 2/3 twice, but we only list it once. So that's called a double root. Or a double root because if you think about it, this really is 12 plus 0 over 18, comma, 12 minus 0 of 18. And in both cases, they're the same thing. Okay, in both cases, they're the same thing, 12/18. And so it's called a double root. It occurs twice, but we only listed once. So it's one. So 2/3 is a rational solution. Is a rational number, so that's going to be a rational solution. And you only have one solution, which is a double root. Okay. Now I want you to notice something. The discriminant here is 0. The discriminant is 0. Notice what happened if the discriminant is 0. If the discriminant is 0, we ended up with a rational solution, and there was only one solution. So we ended up, so the discriminant is 0, we get one rational solution. One rational solution. Okay, now let's get this next one. Number 2. Suppose I had 3x squared equals 6 minus 5x. So 3x squared equals 6 minus 5x. Okay, so in this case, again, remember we got to put it in standard form or general form. And so I'm going to subtract 6 from both sides. So I get 3x squared minus 6 equal, that's 0, so I get negative 5x. Then I'm going to add 5x to both sides. Remember what I do to one side, I do to the other. And I'm going to put this in descending order. Remember in the previous course we talked about descending order, or a previous lesson. Okay, descending order, so I'm going to get 3x squared plus 5x minus 6 equals 0. Alright, now once it's in standard form, I'm going to then determine a, b, and c. So a is 3, that's the coefficient of x squared. B is a positive 5, the coefficient of x. And c is your constant, which is a negative 6. And so I'll plug it back into the formula. So remember the formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so I get x equal the opposite of b. Well, b is 5. The opposite of 5 is a negative 5 plus or minus the square root of 5 squared minus 4 times a. A is 3 times c, which is a negative 6, all over, this whole thing is being divided by 2 times a, which is 3. So I get negative 5 plus or minus the square root of 25, and that 5 squared is 25. Now a negative times a positive times a negative is a positive. So 4 times 3 is 12. 12 times 4 times 3 is 12. 12 times 6 is 72 divided by 6. So adding these two terms here, I get negative 5 plus or minus the square root of 72 plus 25 is 97. All right, 97. And so I then go all over 6. And then the square root of 97, 97 I can't simplify, but notice what happens. So since I can't simplify that, and 97 is not a perfect square, and let's see, no perfect square, will go into 97 other than 1, then that's your answer. We left it like this. Now notice this right here, remember if you separate them, like you would do in my math lab, you'd say negative 5 plus the square root of 97 over 6, negative 5 minus the square root of 97 over 6. And so you'd end up with 2, remember these are irrational, square root of 97 irrational, so that's 2 irrational solutions. All right, so two irrational solutions. All right, now let's look at this one. So suppose we had, all right, let's do this as number 3. So this would be number 3. Suppose we had x squared plus 6x minus 7 equal 0. So x squared plus 6x minus 7 equals 0. So again, we're going to solve this using the quadratic formula. So it's already in standard form. So a is 1, b is 6, and c is negative 7. All right, so when I plug it back into the formula, I get x equal the opposite of b. So b is 6, the opposite of 6 is negative 6, plus or minus the square root of b, which is 6 squared, minus 4 times a is 1, times c, which is negative 7, all over 2 times a, and a is 1. So I get negative 6 plus or minus the square root of 6 squared is 36. A negative times a positive times a negative is a positive. 4 times 1 times 7 is 28, all over 2. So I get negative 6 plus or minus the square root of, now 36 plus 28 gives us 64, all over 2. And then what you notice this time, 64 is a perfect square. So when I simplify the square to 64, I get 6 plus or minus 8 over 2. Now notice that I don't have a square root anymore, so this is going to be rational solutions. And so remember what you did next, which you wrote it as 2 separate solutions. So you say negative 6 plus 8 over 2, negative 6 minus 8 over 2. And negative 6 plus 8 is 2. 2 over 2 is 1. So there's one of your solutions. And remember, 1 is a rational number. Negative 6 and a negative 8 here is a negative 14. And then negative 14 divided by 2 is a negative 7. So you have 2 rational solutions. So notice the discriminant here, the discriminant is 64, and that's a perfect square. So the discriminant is a perfect square. Discriminant is a perfect square. The discriminant is a perfect square. Notice what happens. You're going to get you got 2 solutions, and they're both rational solutions. So you get 2 rational solutions. All right, over here, let's go back over here. Here, the discriminant is not a perfect square. It's positive. Notice the discriminant is positive, but it's not a perfect square. And I ended up with 2 irrational solutions. So here, the discriminant is positive, but not a perfect square. All right, so you get 2 irrational solutions. All right, so far we have this. Notice in all 3 situations, either the discriminant was 0. If the discriminant is 0, you ended up with just 1 rational solution. Okay, if the discriminant is 0, you no longer have a square root. If the discriminant is a perfect square, again, you no longer have a square root, so it's going to be rational. See, the discriminant here was 0, so no square root. So it was rational, but you only had 1 solution, 1 rational solution. Here, the discriminant is a perfect square. It's positive, it's a perfect square. No longer have that square root, so you get rational solutions again, but there are 2 of them this time. So if it's 0, you get 1 rational solution. If it's a perfect square, you get 2 rational solutions. If it is not a perfect square. If it's not a perfect square, you get two irrational solutions. Okay? All right, now let's go back to a previous lesson and let's look at the discriminant. So remember we did number 1 here. This was from part 4. We did number 1. Notice the discriminant is 13. That's not a perfect square. So you get two irrational solutions. Here, number 2, the discriminant is 57. It is not a perfect square. You got two irrational solutions. All right. So number 2, 1/2 plus square root of 57 over 6, and the other is 1/2 minus square root of 57 over 6. Okay, and the next one. Here, the discriminant is 29. So that's not a perfect square. So you got two irrational solutions. Number 4. This time the discriminant is -4. So remember, if your discriminant is -4, if you radicand's -4, you take the square root to get that complex number. You get that imaginary part here. So here, what I want to make a note of is this. If the discriminant is negative, if the discriminant is negative, all right, if the discriminant is negative, you get two complex solutions. You get two complex solutions. Okay? Two complex solutions. So notice right here, discriminant is negative. You got two complex solutions. Now I want you to notice something. See how they look? 3 plus I, 3 minus I? Those are conjugates. So if the discriminant is negative, you're going to get two complex solutions. Now they're going to be conjugates. They're going to be conjugates. So, and they will be conjugates. Which means this. Oops, they will be conjugates, which means this. If 6 plus 2i is a solution, then 6 minus 2i is the other solution. Is the other solution. All right. So if 3 plus I square root of 3 over 6 is a solution, then the other solution is going to be 3 minus I square root of 3 over 6. All right. So the solutions will be conjugates of each other. They'll be complex conjugates. All right. So as a review for this part, let's look at this handout. That's part of your notes from section 1.5. So if the discriminant is positive, so that's going to review this. If the discriminant is positive, you're going to get two unequal solutions. They're going to be different. So you can get two solutions. They're going to be different. So if the discriminant is a perfect square, they're rational. If the discriminant is not a perfect square, they're irrational. Okay? Now, the irrational conjugates means this. The irrational conjugates means that if one is square root of 6, the other one's a negative square root of 6. That's all that means. If one is 4 plus the square root of 3 over 7, and the other one is 4 minus square root of 3 over 7. That's all that means. If the discriminant is 0, remember you only get one solution. In this case, I call it repeated solutions, but it's a double root. All right, so if the discriminant is 0, you get one solution. It's going to be a rational solution, so one rational solution. If the discriminant is negative, you're going to get two imaginary solutions, so two complex conjugates. Okay? All right, so let's look at an example. Now, in this example in my math lab and in the worksheet, this is going to say determine, compute the discriminant, and then determine the number and type of solutions. So let's look at this example. Number 1. So suppose we had x squared minus 4x minus 5 equals 0. So without using a quadratic formula, compute the discriminant. So let's compute the discriminant. So remember the discriminant is b squared minus 4ac. Okay, so we got to determine a, b, and c. So a is coefficient of x squared, so that's 1. B is the coefficient of x, so that's negative 4. And c is your constant, so that's negative 5. So you plug it back into here. So I get negative 4, that's b, negative 4 squared, minus 4 times a is 1, and c is negative 5. So I get 16, negative 4 times negative 4 is 16. A negative times a positive times a negative is a positive. 4 times 1 times 5 is 20. So I get 36. So my discriminant is 36. So the answer here is 36. All right. Now, they want to know the type of solutions. All right, the type of solutions. Well, since the discriminant is a perfect square, since the discriminant is positive and a perfect square, we will get two rational solutions. Two rational solutions. So you get two solutions, but they can be rational. Okay? So if the discriminant is positive, so b squared minus 4ac is greater than 0, meaning positive. Remember, this means positive. So if the discriminant is positive, you get two real solutions. Since it's a perfect square, they're going to be rational. Number 2. Suppose we had 4x squared minus 2x plus 3 equals 0. So again, a is 4, b is negative 2, c is 3. So we've got to find the discriminant. So b squared minus 4ac. So I get b is negative 2 squared minus 4 times a is 4, times c, which is 3. So that's negative 2 times negative 2 is a positive 4. A negative times a positive, so a positive is a negative. 4 times 4 is 16. 16 times 3 is 48. 4 minus 48 is a negative 44. So the discriminant equals a negative 44. Now, since the discriminant is negative, I'm going to get discriminant is negative. So less than 0 means negative. So since the discriminant is negative, your solutions are not real. They're imaginary. So you get two imaginary solutions. All right, so two imaginary solutions. You will get two imaginary solutions, and they will be complex conjugates. All right, now again, that doesn't tell you what they are. If you want to know what the solutions are, you have to actually go ahead and use the quadratic formula. All right, but you do know that you can get two imaginary solutions, and that they're going to be complex conjugates. So if one is 6 plus 8i, the other one is 6 minus 8i. That's all that means. So remember, what that means here, is that if 6 plus 8i is a solution, the other one is, then 6 minus 8i is the other. Okay, that's all that means. All right, number 3. Okay, suppose you had, suppose you had 3x squared plus 4x minus 2 equals 0. So again, we got to make sure in all these cases they were in standard form. So remember we did some a while ago that was not in standard form. But you got to make sure it's in standard form or general form, so you need 0 on this side. So A is 3, B is 4, and C is negative 2. So A is a coefficient of x squared, B is a coefficient of x, and C is your constant. So we're going to find the discriminant. So find the discriminant. So that's b squared minus 4ac. So b is 4, so I'm going to square it. So 4 squared minus 4 times a is 3, times c, which is negative 2. So 4 squared is 16. A negative times a negative is a positive. 4 times 3 is 12. 12 times 2 is 24. And so 16 plus 24 is 40. Okay, now notice this time the discriminant is positive. So remember, the discriminant is positive. If the discriminant is positive, your discriminant is either going to be a perfect square or not a perfect square. So since it's positive, I know I'm going to get two real solutions. Get two real solutions. And since the discriminant is not a perfect square, since the discriminant is not a perfect square, see, 4 is not a perfect square, they will be irrational. These are irrational solutions. All right, and let's see. All right, suppose we had 4. Suppose we had x squared minus 2x equal negative 1. So x squared minus 2x equal negative 1. So again, if I add 1 to both sides, it's got to be in standard form. So I get x squared minus 2x plus 1 equals 0. So a is 1, coefficient of x squared. B is coefficient of x, that's negative 2. And C is your constant, so that's a positive 1. And so I substitute that into discriminant. So remember, you want to find the discriminant. So that's b squared minus 4ac. So b squared is negative 2. B is negative 2, so I square it. Minus 4 times a is 1, times c, which is 1. Negative 2 squared is 4, minus, and that's 4. And so I get 0. So the discriminant is 0. Well, remember, if the discriminant is 0, and you go back to that example we did, the square root of 0 is 0, you're only going to get one real solution, and it's going to be a rational number. So you will get one real solution, and it is rational. And it's one real solution, and is a rational solution. Okay. All right, so that takes care of the situation. So there are 4 situations. Either if the discriminant is positive, we get 2 real solutions. If it's a perfect square, they're going to be rational. If it's not a perfect square, they're irrational, and they can be conjugates of each other. Okay? If the discriminant is 0, you can get one solution called a double root or repeated solution, and it's going to be rational. If the discriminant is negative, we can't take the square root of a negative number, so that's where it's not going to be real, it's going to be imaginary. So no real solutions. In fact, they're going to be 2 imaginary solutions, and they're actually complex conjugates of each other. All right, so that takes care of part 5 on the discriminant.